Okay, this last video hopefully is just going to bring together everything that I've talked about in the previous three. Ultimately, all pieces of matter can be classified as elements, compounds, or mixtures. And so we're going to go through real quick here and kind of ask ourselves, what are the main differences and how do I figure out which one is which? So in saying that, we said that elements can be considered matter can either be considered an element, a compound, or a mixture. And if you've had my class before, you know that I love graphic organizers, and I'm literally doing this right here on the spot. If you can take all this vocabulary and make it make sense in a graphic organizer, it shows mastery of a skill. So in order for something to be an element, what does that mean? Well, we said earlier that elements are pure substances, which means that they are the same throughout. And the easiest thing for elements is that they are located on periodic table. And you will have a periodic table for the rest of the semester. Here in about 2 weeks, I'm going to give you one that you'll use for the rest of the semester. So pretty much just look at it, and if it's located on the periodic table, then it's an element. Okay, so now let's take a look here at compounds. We said that compounds are also pure substances. We said that, sorry, I talk faster than I write. We said that these guys are chemically bonded. Okay, they're chemically bonded together. Well, what does it mean for something to be chemically bonded? Think about H2O. Think about NaCl. So if you see a chemical formula, then it's a compound. Okay, and this right here would be considered a chemical formula. We said that they have a fixed ratio. That's something that nature defines, and we'll learn where that fixed ratio comes from in Unit 5 when we also get to chemical bonding. The other thing to know is that they cannot be separated physically. And what that means is if I gave you water and I said, I want you to separate the hydrogen from the oxygen, you could not do it with physical means. They can be separated, however, with chemical means, and that is something that we will talk about later on. Separated by chemical means. I'm writing with a Crayola twistable because this is all I could find. My kids hid all my pens from me. Okay, so there's our compounds. And the last thing I want to add about this is that the compounds have new properties compared to the elements that make them up. Okay, and that was something we talked about in the compounds video. Okay, now last one. Let's take a look over here at mixtures, and this is the one that can get a little bit big. Let's start by taking a look at homogeneous mixtures. And remember that prefix, homogeneous means same throughout. So a homogeneous mixture, I'm just going to write same. And the best example here is a solution. Solutions are made up of solutes and solvents. Same throughout. You could also use the word uniform throughout as well. And an example of that you could list as Coke. Coke is a homogeneous mixture. You could say milk, okay? Toothpaste, shampoo, so many different things. Anything that's uniform throughout that's made up of multiple substances. The other key thing to remember on mixtures is that their substances keep the properties. So for example, when you're drinking a milkshake, it tastes sweet. Okay, well think about milk, think about chocolate, think about ice cream. All three of those things have sweet flavors, which is why the milkshake tastes sweet. They all maintain their properties. So I'm going to write next to mixture, maintain properties. And what I mean by that is that the elements, the substances that make up a mixture maintain their original properties, whereas in a compound, that's not the case. Okay, I'm trying to go through my head to make sure I'm not forgetting anything here. But I think that's pretty much it. Then let's take a look down here at heterogeneous. We said are not uniform throughout. Okay, and I'm just going to write trail mix. These guys can be physically separated. And then on this one, you've got colloids, and then you've also got suspensions. And so again, on these three new terms we're looking at here, solution, colloid, and suspension, I want you to think solution, very, very small particle size. You cannot see it. Colloid, I want you to think intermediate in particle size, and these are the guys that display the Tyndall effect, which is that scattering of light. And then the last one is a suspension, which is a very visible particle that when we make these, it's going to be very obvious to you because you will see particles. These particles also settle out. So if you leave a suspension sitting out, the particles will settle out on the bottom, which is another characteristic of suspensions. And guys, that's pretty much what I need you to know about those terms. We need to be very comfortable using them, and just let me know what questions you have.